All right, ladies and gents, guys, gals, non-binary pals, we are going to talk about graphing rational functions. Okay, so when you have a rational function, and I'm so sorry, I forgot my y equals. When you have a rational function like this, you want to run through the list of things that you need to figure out all the features of that rational function. So those features include the intercepts. So we have x-intercepts, we have y-intercepts, and then we have asymptotes. So we need our vertical asymptotes. And remember, the vertical asymptotes are the ones where that's how we save the puppies. And then we have our end behavior asymptotes. And that tells us what the function is doing at the end of the x-axis. So all the way to the left. Sorry, I'm gesturing with my hands right now, and I know you can't see me. All the way to the left and all the way to the right on the y-axis, or the x-axis. What is the function doing? So let's start with the x-intercepts. How do we find our x-intercepts? Where do we look for the x-intercepts? Anybody? Anybody? You are correct. We look right here at the tippy top of the function. Whoa, it turns colors. I didn't know it was going to do that. We look at the top. So the x-intercepts come from, please remember, the numerator. So we're looking at the top, which makes sense because the x-intercepts happen when y is equal to 0. And so where's y? Y is right there. So if we set that equal to 0, that means that the top must be 0, not the bottom. Because if the bottom is 0, we're dividing by 0, it's undefined, puppies. But if the top is 0, that just means that y is equal to 0, the whole function is equal to 0. So we're looking for places where the numerator is equal to 0. So I'm just going to say to myself, all right, self, 2x plus 5 equals 0, and then I want to figure out what x is. So how do I get x by itself? I'm going to subtract 5 on both sides. So I have 2x equals negative 5, and then I'm going to divide by 2 on both sides, which means I'm going to go up here so I don't go down to the y-intercept. X equals negative 5 halves. Don't be afraid of fractions. It's okay. We're going to make it. Okay. So I know my graph crosses at negative 5 halves. So I'm going to write that over here in an intercept form. Negative 5 halves, comma, 0. That's my my x-intercept. So I've got that down. Donezo. Y-intercepts. Where do the y-intercepts happen? Okay, so the y-intercepts happen, if you recall, when the x value is equal to 0. So the only way we can actually do that on this function is actually to set x equal to 0. So I'm going to take my whole function and I'm going to say, okay, let me draw a line here. I'm going to say, let's use, guys, what color do you want to use? Let's use red? Let's use red. 2 times 0 plus 5 divided by 0 minus 8. So 2 times 0 is 0, 0 plus 5 is 5, and a 0 minus 8 is negative 8. Negative 5/8, another fraction? Are you kidding me? That's fine. Don't be afraid. I want to challenge you. I want you to think about fractions. Fractions are your friends. Fractions are friends, not food. I saw Finding Nemo recently. That's where that came from. Sorry. Okay, so I'm going to write down my y-intercept in intercept form. That's 0, comma, negative 5/8. Put that in parentheses, and I'm done with that. Okay, so now we're on to vertical asymptotes. And where, my friends, do vertical asymptotes come from? And this, remember, are the puppies. Should we start? We should draw a quick puppy, obviously. So let's see if I can. Here's little ears. Oh. Here's little eyes. Oh. Here's little nose. Oh. Fill in your nose, buddy. And then here's his little face. And he's all like, hey, I'm a puppy. Yay. Well, that's not my best, but that's fine. Okay, so where do puppies come from? Sorry. That's another conversation. Where do vertical asymptotes come from? Looking back up here at the function, the vertical asymptotes come from the bottom. The denominator, wherever that is equal to 0, you have a vertical asymptote. We don't want to touch that. So that means I'm going to say to myself, where is the denominator equal to 0? So x minus 8 equals 0. Where does that happen? How do I solve for x? I'm going to add 8, so x is equal to 8. So that, my friends, is a vertical asymptote. And you can leave it just like that because that's not an intercept, that's a line that I'm going to draw on the graph. Okie doke. Okay, now let's talk about end behavior asymptotes. And I'm actually going to go ahead and move to another slide. Okay, so before we start talking about end behavior asymptotes, what we need to do is we need to figure out, is this function proper or improper? And remember, the way that you do that, and guys, look, I just found this. I can use little pointers. Look at this. Look at, hey! Look at this. Wait, look at this. Look at this. Wong, wong. It's a lightsaber. Okay, so, the way you figure out if it is proper or improper is you need to look at the degree on top and the degree on bottom. And remember, how do we figure out where or what the degree is? We look at the exponents. So the degree on top, the biggest exponent I see on my variable is 1. Same thing on bottom. So they have the same degree. So if they have the same degree, then what do I look at to figure out what has the higher value? So if they have the exact same degree, the thing that I'm going to look at is actually, that's not what I want to do. I look at the leading coefficient, the number in front of the x value. So you can see that here, that is a 2. Here, there is no number, but how many x's are there? There's 1 x. So I have a 2 on top and a 1 on bottom. So this is only if they have the same degree. Should I write this down? I'll write it down. Okay, so we are looking at the leading coefficient only if we have the same degree. And the leading coefficient is usually the number out front, but the best way to check it out is to make sure that it is the number in front of the variable with the biggest exponent. Biggest exponent. Oh my god, I love the lightsaber. This is so much fun. Okay, so here, the 2 on top is bigger than the 1 on bottom, so I know for a fact that these guys are, in fact, improper. This is an improper fraction, which means to find the end behavior asymptote then, what I need to do is, anybody remember? Polynomial long division. That's right, strap yourself in, folks, for the best ride of your life. So we know we're going to do some polynomial long division here. I meant to ask, and I should have asked before I erased all that, what do we do if the function is proper? If the value on top is less than the value on bottom? If that is the case, then we don't need to do polynomial long division. The end behavior asymptote just stays at y equals 0. But that's only if the function is proper. I'll write that down. If the function is proper. If it is not proper, then you need to do polynomial long division to figure out what's going on. Okay? Okay. So let's get to it. Let's do some polynomial long division. So I have 2x plus 5 divided by, oops, sorry, there was a smudge. I have to delete that. Erase. Divided by x minus 8. Okay, so remember, we are looking at the front terms only here. Oh my god, I forgot how they change color. I love it. So how many times does x go into 2x? What do I need to multiply times x to get to 2x? If you said 2, you are correct. So I'm going to put the 2 right up here on the top. Now what do I need to do? I'm going to multiply that 2 times both of those guys down there. So 2 times x is 2x, and then 2 times negative 8 is in fact negative 16. Now I'm going to subtract all of that to figure out what's left over. So 2x minus 2x, nothing. 5 minus a negative 16. Minus a negative. What happens when we're minusing a negative? That means we are adding. So basically this is 5 plus 16. Okay? So 5 plus 16, I believe, is 21. So now my question is, y'all, how many times does x go into 21? What can I multiply times x to get to 21? Nothing. What does that mean? 21 is my remainder. So the way I would write that is 2 plus 21 over x minus 8. That would be my answer. Now, here is the thing. For end behavior asymptotes, you don't need the remainder. That means I don't even need to worry about this part. This is correct. That's what we need to do for polynomial long division. But for the end behavior asymptote, the only thing I need to worry about is this bit right here. That 2 right there. So my end behavior asymptote is going to be y equals 2. That is the solution to my polynomial long division problem without the remainder. I don't need the remainder for end behavior asymptotes. Okay, guys, it's time to graph. Okay, so here we have a graph. We have all of our delightful information over here. So what we're going to do is we're just going to start putting in what we can. So let's start with the x-intercepts. We only have one x-intercept, and it is right there at negative 5/2. But we also have a vertical asymptote at 8, so I need to make sure that I have enough room on my x-axis to get up to 8. So when I'm labeling my axis, excuse me, pardon me, I'm going to make sure that this side can get all the way up to 8. So here it goes. 1, 2, 3, 4, 5, 6, 7. There's 8, 9, 10. I'll give it to 10. I'm going to try to keep the same spacing on the other side, roughly. It doesn't have to be perfect because it's just a sketch of a graph. Sorry, things moved around. Okay, now my y-axis, I know I have a y-intercept at negative 5/8, but then I also have, there's my y-intercept right there, but then I also have this end behavior asymptote, which is going horizontally at y equals 2. So I need to make sure I can get all the way up to 2. So I'm going to go 1, there it is, 2, 3, 4. I'm going to try to do the same spacing down on the bottom. And then, guys, let's go ahead and just put, let me try to zoom in. Whoa! Let's put some labels just on the first couple so I know what we're doing. So this is 1, that's 2, that's 3, 1, 2, 3. It's always good to have some labels on there, even if it's just 1, 2, 3, 1, 2, 3, just so I kind of know what the scale is. So if I can get this zoomed back. There we go. Okay, so now let's go ahead and put on all of the stuff that we have. So I know I have an x-intercept at negative 5/2. So negative 5/2 is just about the same as negative 2.5, comma 0. So I'm going to go over here to my graph, and I'm going to put a spot. So here's negative 1, negative 2. So I'm going to put a spot right about there. So negative 2.5, bling. Okay. Then I also have an asymptote, a vertical asymptote at x equals 8. So I'm going to go all the way out to 8. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, this lightsaber, y'all, is just my favorite thing in the world right now. Okay, so I'm going to put a vertical asymptote. I'm going to use red for my vertical asymptote, and it's going to be, of course, well, that's not very good. It needs to be a dotted line. So 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8. Okay, good. Now let's put my y-intercept. So my y-intercept is negative 5/8. So that's just a little over negative 1/2. So if we look at our y-axis, here's 0, here's 1. So I'm going to be right about there. So let me put a point right here. And then my end behavior asymptote is y equals 2. So I'm going to go over here. Here's 1, here's 2. So my end behavior asymptote is going to be going horizontally like that. So here we go. 1, 2. Oh no, not blue. It's red. Asymptotes are red. Come on. Okay, like so. Okay, so far so good. We have some asymptotes. We have some points. Now, to figure out what the graph is doing, we're going to make a sine line. A sine line. I feel like the sine line needs its own theme song, but I don't know of one. If you need to know the sign, then just draw a line. I don't know. We'll figure out something. So on the sine line, remember, you need to put everything that is crossing the x-axis. So I only see two things on the x-axis. I see this point right here, and then I go, that point's on the y-axis, not the x-axis. So nothing, 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 and then the vertical asymptote at 8. So there are only going to be two things on my sine line. So here is negative 2.5 or negative 5/2, and then here is 8. So I need to figure out what is happening down here with my function. For numbers below negative 2.5, is my graph positive or negative? So let's think about this. Let's choose a number below negative 2.5. Let's just say, for the sake of being super easy, negative 5. I like negative 5. It's a nice number. I can use any number down there. So negative 5, when I plug negative 5 in back up here for the x's in my original function, 2 times negative 5 is negative 10 plus 5. That's going to leave me with a negative number, so negative. And then on the bottom, negative 5 minus 8, that's also going to be a negative number. So guys, negative divided by a negative, what kind of number is that going to be? If you said positive, you are correct. So let's write in big numbers, positive. Okay, so you might be thinking to yourself, that doesn't make sense, because if it's going to be positive over here, that means I'm going to be up here, and look at my little x in it. So am I supposed to like draw my graph and I'm going to be like, and the answer to that is no. Since it's positive, all that means is that I need to be on top of the x-axis. So my graph is still going to get real close to this asymptote, but it's never going to jump above it. But this is all going to be positive, because here's positive 1, positive 2. So my graph is always going to be positive. So that makes total sense to me. Now, for our sine line, let's look at a number between negative 2.5 and 8. Guys, we've already done that. What number is between there? It's 0, and if you look right here, we've already found that when you plug in 0, you get a negative number, just like we did for our y-intercept. So that's going to be negative. Okay, let's pick a number above 8 for this last part of our sine line. I'm going to use 10, just because I like 10. It's a nice round number. So going back up here, if I plug in 10 for all my x's, 2 times 10 plus 5, that is going to result in a positive number, so positive. And then 10 minus 8, that is also going to result in a positive number. So that's going to be a positive divided by a positive, which, folks, if you're paying attention, is in fact a positive number. Okay, now this is a little weird because I didn't draw my graph very well. I'm going to go ahead and I'll just confess to that. I was not paying very close attention. So I'm going to kind of extend my asymptotes up a little bit. This positive number right here does not mean I'm going to be positive down here, because I don't have any x-intercepts down here, so that it doesn't make sense that I'll have a graph down here. Positive numbers up here are going to be on this part hugging the asymptotes, so coming like kind of hugging the asymptotes just like that. Let's draw this in. Let's just go ahead and see what it looks like. So on the left side, right here, I know it's positive, then it goes down to a negative after it hits this x-intercept right here. So I'm going to start over here. Here we go. Janky. Okay, I'm doing it again. Dun, dun, a little better. Okay. Well, that's not my best, but we're going to call it good. So I'm hugging the asymptotes up here and down here. I'm going to get real close to the asymptotes on both sides. And then, since I'm positive up on the last part, my graph is going to be up here, being all positive with its bad self, hugging the asymptotes again up here. Ladies and gents, that is my graph. Whew, that was fun. Let's do one more together. I'm going to go much faster. If you need me to slow down, well, you can't tell me to slow down since I'm on the other side of a camera internet thing. But just rewind this, pause it, see what you need to see, and let's do it. Wait, before I go, I wanted to show you this on Desmos to kind of double check and make sure that you understand that I'm graphing this correctly and that it looks correctly when you graph it and all that good stuff. So I'm going to go grab a photo. I'm going to go graph this on Desmos, which is an internet graphing tool, and bring it back and show you. Watch this. Here we go. Shablam! It was supposed to look like magic. I don't know if it did. Anyway, y'all, look at this. So just like on the graph that we did over here by ourselves, I put this in a Desmos and I have to manually put in the asymptotes, but still, all of our asymptotes that I plugged in matched up with the ones that we calculated, and the graph did exactly what we thought it was going to do over here. So even though this doesn't look super fancy, it definitely is correct because it matches up with the real one. I just thought that was super exciting. I wanted to show you. Okay, now let's go graph the next one. All right, folks, let's do this one. So we are going to start with x-intercepts. So remember, x-intercepts come from the numerator. Now, I don't know what x is in the numerator. What's going to make this a heck of a lot easier, y'all, is if I factor this part up here. So I'm going to do some factoring. I wonder why the 3 was the only one that changed here. That was weird. I'm going to do some factoring here. And that's just, you're using this guy. So I have multiplying to -3 and adding up to 2. So that's going to be 3 times -1. So that's going to be x plus 3 and then x minus 1. So that means my x-intercepts are when x plus 3 equals 0 and when x minus 1 equals 0. So that means x is -3 and x is positive 1. Okay, so I factored the top, factored up here, and then using my little x thing, and then I set each one of those equal to 0, and boom, there are my x-intercepts. I should write these in intercept form, so -3, 0, and 1, 0. Okay, now let's check out my y-intercepts. My y-intercepts, remember, I'm going to set x equal to 0. So that means I'm going to go back to my original equation. So that means I'm going to have, let's use red, I'm going to have y equals 0 squared plus 2 times 0 minus 3 over 0 plus 1. So that's going to be 0 squared is 0, 2 times 2, so 0 squared is 0, 2 times 0 is 0, 0 and -3 on top. And then on bottom, I just have 0 plus 1. So that's going to be, oh, just 1. So that's just -3. So my y-intercept is 0, -3. Okay, then we need to talk about vertical asymptotes, and that's puppies. So I'm looking at, sorry, my atrocious handwriting. I'm looking at the denominator. So the only thing I have in the denominator right now is x plus 1. So I'm going to take x plus 1, and I'm going to say, hey, x plus 1, you are equal to 0. And then I'm going to say x equals -1. So that's my vertical asymptote. And then for my end behavior asymptote, I've noticed up here, if you look at my function rather, the degree on top is 2, the degree on bottom is 1, which means, y'all, I'm going to need to do some polynomial long division because this is improper. Remember, if it's proper, the asymptote is just y equals 0. I don't have to do anything. But if it's improper, I need to do some polynomial long division, which is super fun. So let's hop to it. I'm going to use purple for some polynomial long division right now. So I have x squared plus 2x minus 3, then divided by x plus 1. So remember, I'm just looking at these first guys right here, that guy and that guy. So x times what will give me to x squared? If you answered x, you are correct, 1x. So then x times x is, anybody? X squared, good. And then x, oh wait, let me get a red color. X times positive 1 is in fact just 1x. Then I'm going to subtract all of that. So x squared minus x squared is in fact just, well, nothing. So then 2x minus 1, oh, I forgot the x. How did you guys let me forget to write the x right there? There it is. 2x minus 1x is just 1x. Then we're going to bring that negative 3 on down. So minus 3 right there. Then again, we're just looking at the first terms. So this guy, oh, I scribbled instead of using a highlighter. This guy right here, first terms. So x, this guy, times what will give me to x? X times what equals x? If you said 1, you are the lucky winner, x plus 1. So then, same thing. What's 1 times x? That is just x. And then what is 1 times 1? That is just 1. So then let's subtract that. So x minus x is nothing. And then negative 3 minus, don't forget this minus, negative 3 minus 1, then cuidado, be careful, is negative 4. So now, how many times does x go into negative 4? X and nothing. Negative 4 is our remainder. So what I'm going to write up here is minus 4 over x plus 1. That is the answer to this problem. But remember, for my end behavior asymptote, which part do I need? I don't need the remainder. I only need this part right here. That's it. So my end behavior asymptote, I can just say, let's use purple again. I can just say, what? Not purple highlighter, guys. Y equals x plus 1. That's going to be my end behavior asymptote. Okay, let's graph this real quick. I'm going to say I'm moving on to the next one, so pause it, because I'm moving on to the next slide. Pause it if you need to look over all that stuff, and I'm going to graph. Let's go. All right, y'all, so here is my fraction. Here is all my list of features of that function. So let's graph it. So I'm going to start out by doing the x-intercepts and the VASI, because those are the things that go on the x-axis. So I know that I have to have a negative 3 on my x-axis, a positive 1, and a negative 1. So I'm going to start going toward the bottom to make sure I get that negative 3 on there. So I'm just going to go 1, 2, 3, 4, 5, like that. And then let's do the same thing on the other side. I managed to get 6, huzzah. And then on the y-axis, I know that I have a y-intercept here at negative 3. And then my end behavior asymptote is actually not a straight line. This is actually going to be a slant asymptote like that. It's going to go up and down like that. But my slope, the number just in front of the x, is just 1. So that doesn't really have too much bearing on my y-axis. So it can just be just about the same as the x-axis. So something like that. And then, like I said on the last one, we're going to zoom in and we're going to label. So it's going to be 1, 2, 3, 1, 2, 3, just to make sure it's all labeled. I know what we're talking about. Okay, so, okay, wait, let's, okay, right about there, okay, sweet. So, let's start with our intercepts. So I have an intercept at -3 on the x-axis, y equals -3, and +1 on the x-axis. So here is -3 on the x-axis right there, and here is +1 on the x-axis right there. Then I have a y-intercept at 0, -3. So let's go ahead and throw that one on there. So -3 is 1, 2, 3. It's going to be right there. So now let's look at the asymptotes. So for my vertical asymptote, this one's pretty easy because I've just got x equals -1. So I'm going to go over to my x-axis. I'm going to go back here to -1. Boom. I'm going to have my vertical asymptote going up and down right here. And remember, this is the one we can never ever cross because we're saving the puppies. So that's my vertical asymptote. Now, the end behavior asymptote. Whoa, this is something crazy. Y equals x plus 1. Y'all, shout out way back when to AGS1, even before AGS1, when you were graphing lines. So remember, if you think about this in terms of y equals mx plus b, you know how to graph these lines. This is the exact same thing. B is the y-intercept, m is the slope. So this is where +1, that's where I'm crossing the y-axis, and then my slope, there's no number in front of the x, which means there's one x there. So I'm going up 1 over 1, rise over run, up 1 over 1, up 1 over 1. So let's look and see how that's going to look on the graph. So first, y-intercept, +1. So right here, +1. I'm going to put a little point right there just for my, not horizontal asymptote, my end behavior asymptote. And then my slope is going to be up 1 over 1, up 1 over 1. So let's do that. Up 1 over 1 puts me right there. Then up 1 over 1 again puts me right about there. Up 1 over 1 again puts me right about there. So here is my end behavior asymptote. Now, I know you're probably freaking out right now. You're like, this is bananas, Mrs. Ray. What do you think you're trying to do to us? This is not, y'all, this is fine. This is great. This is what rational functions look like. No problem. I'm super excited about this right now. Okay, so let's get into our sine line. Here's a sine line. If you want to know the sign, just draw a sine line. Was that our jingle? I've forgotten it already. So let's figure out what is crossing the x-axis. So we're going across here. Boom, I have a cross here at, is that -3? So -3. The next cross happens, boom, right here at -1. -1. And then we keep going, the next cross, boom, right there at +1. And then nothing. So these are the three things that I need to look at. Which one do we already have done? We've already done the y-intercept right here, which is when x equals 0. So we already know that between -1 and +1, we already know that the sign right there is going to be negative. Okay, so let's look and see what happens when we are down below -3. So let's say -5. Let's plug in -5. So going back here, I'm actually going to use my factored form because that makes it a little bit easier for me to think about this. So -5 plus 3, that's going to be a negative. -5 minus 1. So on top I have a negative times a negative if I plug in a -5. So on top, that is going to be a positive, right? Negative times negative, that's a positive. And then on bottom, I have -5. If I'm using -5 plus 1, that's going to be a negative on bottom. So y'all, what is a positive divided by a negative? That is, in fact, if you said negative, you're exactly right. Now, let's look at between -3 and -1. -3 and -1, let's shoot -2. Sounds good. So going back up here, -2 plus 3, that's going to be a positive. -2 minus 1, that's going to be a negative. So on top, I have a positive times a negative, which is a negative on top. And then on bottom, what have I got going on bottom? Negative 2 plus 1, that's going to be a negative on the bottom. So guys, negative on top, negative on bottom. When I plug in negative 2, negative divided by a negative gets me a positive. Okay, so I've got 3 done so far. Got a negative sign over here, positive, negative, and then let's do something above 1. What number do you want to do? I like 10 just because it's nice and round and it works very easily. You can use whatever you would like that is above positive 1. 2 would even be a great. You know, use 2. Let's use 2. 2 is easier. So 2 plus 3, that's a positive. 2 minus 1, that's a negative. Uh-oh. Wait. 2 minus 1? That's not a Lindsay Ray. I apologize, y'all. 2 plus 3 is positive. 2 minus 1 is positive. I'm sorry. It's early. It's not early. I don't know. Okay, so that's a positive on top. And then on bottom, I've got a 2 plus 1. That's most definitely positive. So positive. So guys, a positive divided by a positive is in fact a positive. So let's get to drawing our graph. So on this side of negative 3, I'm going to be negative. I'm going to be down here in the bottom. On between negative 3 and 1, I'm going to be up here on top, which makes sense because I'm going to be coming up and hugging this axis. When I go down, I'm going to be hugging this asymptote. Then between here, I'm going to be negative, which makes sense because I'm going to be hugging this asymptote for puppies, and then coming up. And then it looks like positive, which again makes sense because I want to be getting real close to that asymptote. So let's see what this looks like. Da-da-da-da-da. Oops, that's a that's a lightsaber, not a pencil. Here we go. Yeah, yeah. And then down here, there's going to be nothing happening in here. There's going to be nothing happening in here. That's totally fine. And then I'm going to go, da-da-da-da. Oh, highlighter. Why always do that? Get rid of that. Get rid of the highlighter. Delete. Pencil. Da-da-da-da-da-da-da-da. Getting real close to those asymptotes. Y'all, that's gorgeous. That's gorgeous. Look at that. That's beautiful. Let's check Desmos just to make sure it works out. I'm going to go over and grab that picture and bring it on back. Alright, so y'all, I went to Desmos and I graphed this, and then I also had to graph in the asymptotes. But if you look at it, oh my gosh, it matches up just perfectly. I have my intercepts in exactly the same spots, 1 and negative 3. I have my slant asymptote matches up perfectly, and my vertical asymptote matches up perfectly. So yeah, I would say that this is a success. Okay, guys, if you have any questions, send me an email, let me know what's up, and tomorrow we'll do a little bit of a warm-up before the test, and then we're gonna knock this out of the park. And I almost forgot, guys, who's good at math? Let's say it on the count of 3. 1, 2, 3. I am good at math! I hope you said it with me, because my cat is now very angry with me. But that's fine. That's fine. It's worth it. Y'all, I will see you tomorrow. Toodles!